All right, so we're diving deep into Node.js design patterns today. Looks like someone's ready to level up their Node skills.
Absolutely.
We're cracking open Node.js design patterns, third edition.
Yeah.
Trust me, you are in for a treat. This isn't just some dry rundown of patterns. This is about understanding the soul of
It
Node.js.
really is about the Node way.
Uh-huh.
This philosophy that kind of permeates the entire ecosystem.
Exactly. It's not just about what the patterns are, but why they work so well with Node. And the book really dives deep into that. So let's unpack this whole Node way, shall we?
Yeah.
It seems to center around this idea of building with small, really focused modules, each one doing one thing really, really well.
Think of it like a well-organized toolbox.
Sure.
Each tool has its specific purpose, and they all work together seamlessly.
I like that. But there's a catch, right? Node.js is single-threaded. It can only do one thing at a time. How on earth does that handle the demands of a busy web server?
Well, that's where things get really interesting. Because of that single-threaded nature, Node.js relies heavily on non-blocking asynchronous operations. Instead of waiting for a task to finish before moving on, it delegates tasks and says, hey, I'll get back to you when that's done, and moves on to the next request.
So it's juggling a ton of requests without getting bogged down.
Yeah.
But how does it actually pull that off?
Under the hood, it's using this I/O engine called Labouv.
Okay.
Labouv's the master conductor.
Yeah.
It orchestrates all these asynchronous operations and abstracts away the complexities of different operating systems.
It's amazing how much is happening behind the scenes. Okay, let's zoom in on the modules themselves. The book mentions CommonJS. Is that how Node.js keeps its code organized?
Yes. CommonJS was like a game changer for JavaScript.
Mm-hmm.
It brought order to the chaos by introducing the require function.
Okay.
Finally, a way to import functionality from other modules cleanly and efficiently.
So require is how we pull in those small specialized modules
Yes.
to build our Node.js applications.
Uh-huh.
But the book mentions that require is synchronous. And that seems like it could cause problems in an asynchronous world.
You're absolutely right. When you call require, Node.js stops everything to locate and load that module. It follows a specific algorithm, searching through directories, resolving paths to find exactly what you're looking for.
So it's like a detective, following a trail of clues to find that missing module.
Exactly. And once it finds the module, it executes the code and stores the result in a cache.
Okay.
This caching is super important because
okay.
it prevents the same module from being loaded over and over again, wasting precious resources.
Right.
Yeah.
But if require is synchronous and we're working in an asynchronous system, doesn't that create a conflict?
Right.
Imagine a module that needs to fetch data from a database.
Yeah.
That's not going to be instantaneous.
You've hit on a crucial point, that synchronous nature can indeed cause issues when dealing with inherently asynchronous operations. Think about it. You're trying to fit a square peg into a round hole.
So how do we resolve that?
Don't worry, the book has some clever solutions up its sleeve. We'll delve into those a bit later.
All right, you've got me hooked. But for now, let's get back to those asynchronous patterns. The most basic building block, as the book explains, is the callback.
Right.
What are those all about?
Callbacks are the workhorses of asynchronous Node.js. You're essentially saying, hey, when you're done with that task, execute this function. It's like leaving a note for someone to call you back when they're free.
So you're not waiting around. You're giving instructions for what to do later. But I've heard horror stories about callback hell. Is that something we should be worried about?
Callback hell is a real danger if you're not careful. Imagine this deeply nested pyramid of callbacks, each dependent on the one before it. Trying to follow the logic of that code would give anyone a headache.
It sounds like a tangled mess of code.
Yeah.
How do we avoid creating that monster?
The key is to keep your code clean, structured, and modular. The book offers techniques like early return, where you exit a function as soon as an error occurs or a condition is met. This prevents unnecessary nesting.
So it's like hitting the brakes early to avoid a pileup?
Exactly. Another strategy is modularizing your code, breaking down those massive callback structures into smaller, more manageable functions. Not only does this make your code more readable, but it also makes it easier to test and maintain.
All right, so we're breaking things down
Yeah.
and keeping it organized.
Right.
But sometimes you need things to happen in a specific order. How do we manage that when Node.js is all about doing things concurrently?
Well, that's where techniques for sequential execution come in. It's like choreographing a dance. Each step needs to happen at the right time. You can use nested callbacks, where one callback triggers the next in a sequence, or leverage libraries like async to manage the flow of execution.
So async is like the choreographer, making sure all the dancers hit their marks at the right time.
That's a great analogy. It provides a higher-level way to express asynchronous operations, making your code easier to read and reason about.
Sounds like async is a valuable tool for taming asynchronous complexity, but the book goes beyond callbacks and introduces promises. How do they fit into the picture?
Promises are a huge step forward from callbacks, offering a cleaner, more elegant way to manage asynchronous operations. They're like a contract.
Uh-huh.
You're promised a result at some point in the future.
And why are promises such a big deal?
Think of it like this. Callbacks can get really messy and hard to follow. Promises, on the other hand, provide a more structured way to handle success and failure paths, leading to code that's easier to read, understand, and maintain.
So it's like upgrading from a clunky old phone to a sleek new smartphone. Everything is just smoother and more intuitive.
Exactly. Plus, promises handle errors gracefully. Instead of those deeply nested error callbacks, promises have a dedicated .catch method that handles errors cleanly and predictably.
No more error handling nightmares. I'm sold on promises. But the book also mentions something called Promises A+. Is that some kind of advanced promise?
Promises A+ is actually a specification that ensures interoperability between different promise libraries. It's like a universal language that all promises can understand, ensuring they work together harmoniously. Think about how frustrating it would be if you couldn't charge your phone because every brand used a different charger.
That would be a nightmare. Standards are definitely important. Okay, so promises are clearly the way to go, but the book mentions async await. How do those fit into the promise equation?
Now, async await is where things get really exciting. It's like magical sprinkle dust that makes your asynchronous code look and feel almost synchronous.
Wait, so you're saying async await lets us write code that looks synchronous, even though it's doing all those asynchronous things in the background?
Exactly. It's a beautiful illusion that makes asynchronous code much easier to write, read, and reason about. You can ditch those confusing callback pyramids and write code that flows naturally.
This is blowing my mind. I can't wait to see how it works in practice.
And we will. But it's crucial to remember that even with async await, Node.js is still single-threaded at its core. The magic lies in how it manages those asynchronous operations behind the scenes.
It's like a magician performing a complex trick, but we only see the amazing outcome, not the intricate mechanics behind it.
Exactly. The book delves into the mechanics using a task queue,
Okay.
which is like a backstage crew managing all the asynchronous tasks, ensuring they're executed in the right order without blocking the main thread. It's fascinating stuff.
This is all so fascinating. But before we go down that rabbit hole, the book shifts gears and starts talking about streams. Are streams another way to manage asynchronous operations in Node.js?
Streams are more than just another tool in the asynchronous arsenal. They're essential, especially when you're working with large amounts of data
Okay.
or performing I/O-heavy operations.
Okay, so streams are for serious data handling.
Yeah.
Why are they so crucial?
Imagine you're downloading a huge file. A traditional approach would be to wait for the entire file to download
Right.
before doing anything with it.
Yeah.
With streams, you can start processing the data in chunks as it arrives. It's like reading a book chapter by chapter,
Okay.
instead of waiting to devour the entire thing at once.
That makes a lot of sense. It's much more efficient to work with data in smaller chunks, especially when you're dealing with huge data sets.
Exactly. And the book really drives this point home by contrasting the limitations of buffered APIs, which load everything into memory at once, with the efficiency and elegance of streams. It's like comparing a tiny bucket to a powerful fire hose.
All right, I'm starting to see why streams are so powerful. But the book mentions different types of streams: readable, writable, duplex, and transform. What's the deal with all these different types?
Each type serves a distinct purpose in the data flow pipeline. Think of it like a plumbing system. You have pipes for bringing water in, pipes for sending it out, and pipes for transforming it along the way.
So it's a whole system for managing the flow of data. Can you give me a real-world example of how these different stream types are used?
Absolutely. Imagine you're building a real-time log analyzer. You can use a readable stream to continuously read data from a log file,
Okay.
a transform stream to parse and filter the log entries, and a writable stream to write the processed data to a database or dashboard.
So it's like a data assembly line, each stream performing a specific task on the data as it flows through the system.
Very cool. But what about back pressure? The book mentioned that term, and it sounds a bit intimidating.
Back pressure is a critical mechanism for preventing a system from being overwhelmed by data. It's like a safety valve that regulates the flow, ensuring smooth and efficient operation.
Ah.
Imagine a stream trying to push data faster than the receiving end can handle. Things could get messy.
So it's like a traffic control system preventing data gridlock.
Mhm.
But how does back pressure actually work?
It's a collaboration between the stream and the consumer. The stream can signal when it's getting overwhelmed.
And the consumer can respond by slowing down the rate of consumption. It's a beautiful dance of push and pull, ensuring a harmonious flow of data.
That's an elegant way to manage data flow. But the book goes beyond these fundamental stream types and delves into advanced stream patterns like multiplexing and demultiplexing.
Right, that's where things get really interesting. Multiplexing is like sending multiple TV channels over a single cable.
Okay.
You can combine multiple streams into one, send it over a network, and then split them back into their original channels at the other end.
So it's like data packing, combining multiple streams into a single unit for efficient transmission. That's mind-blowing.
It's a powerful technique, especially in scenarios where you need to optimize network bandwidth
Right.
or manage multiple data sources efficiently.
Okay, I'm starting to see how streams are not just about reading and writing data, but about orchestrating like complex data flows. This is way more powerful than I initially realized.
Yeah.
But before we dive deeper, let's shift our focus to something a little more familiar. Traditional design patterns. The book covers a whole section on these, starting with creational patterns.
Right.
I remember these from my object-oriented programming days. Are these classic patterns still relevant in the Node.js world?
Absolutely. While Node.js brings its own unique flavor to software development, the fundamental principles of good design remain timeless.
Right.
Creational patterns are all about controlling how objects are created, and they're just as valuable in the Node.js ecosystem.
So it's not just about writing code, it's about writing well-structured, maintainable code.
Yes.
And these patterns provide a blueprint for doing just that.
Precisely. And the book showcases how these patterns can be applied effectively in the Node.js context. Let's start with the factory pattern. Remember that one?
Vaguely. It's about creating objects without specifying the exact class to be created, right? Like a magical factory that can produce different types of products depending on the order.
You got it. The factory pattern provides a level of abstraction that makes your code more flexible and easier to maintain. Imagine you're building an e-commerce platform. You could have a product factory that creates different types of products, like books, electronics, or clothing, based on the input it receives.
So instead of hard coding the creation of each product type, you have a centralized factory that handles it all. That's a much cleaner and more scalable approach.
Exactly. And the book provides concrete examples of how to implement the factory pattern in Node.js,
Okay.
showcasing its power and versatility.
Okay, I'm starting to see the value of these classic patterns. What about the builder pattern? How does that one differ from the factory pattern?
While the factory pattern is about creating different types of objects, the builder pattern focuses on constructing complex objects step by step. It's like having a blueprint or a set of instructions that guide you through the process.
So it's about managing the complexity of object creation, especially when you have objects with many optional or configurable attributes.
Exactly. Think about building a pizza. You could have a pizza builder that allows you to choose the crust, sauce, toppings, and other options in a specific order, ensuring that you end up with a delicious and well-constructed pizza.
That's a great analogy. So the builder pattern is like having a master chef guiding you through the pizza making process. It's all about clarity and control.
Precisely. And the book highlights how this pattern can be applied to building complex objects in Node.js, making your code more readable and maintainable.
Okay, I'm getting hungry just thinking about pizzas. But let's move on to the next pattern. What about the revealing constructor pattern? That one sounds a bit mysterious.
The revealing constructor pattern is all about controlling object creation and enforcing immutability. It's like building a house with a specific set of features, and once it's built, those features can't be changed.
So it's about creating objects that are locked down, preventing accidental modifications.
Exactly. Think about building a secure system. You might use the revealing constructor pattern to create user objects with specific permissions. Once the object is created, those permissions are set in stone, ensuring that no unauthorized modifications can occur.
So it's like a security seal guaranteeing the integrity of the object state. That's a powerful concept.
It certainly is. And the book delves into the nuances of implementing this pattern in Node.js,
Okay.
highlighting its benefits and potential pitfalls.
Okay, we've covered 3 creational patterns so far. What about the singleton pattern? How does that one work in the Node.js context?
The singleton pattern ensures that you only have one instance of a particular object throughout your entire application. Think of it like a global configuration object that needs to be accessed from various parts of your code.
So it's like having a central control panel that everyone can access. But the book mentions some caveats when using singletons in Node.js. What's the issue?
The traditional way of implementing singletons, which relies on global variables, can clash with Node.js's module system. Modules in Node.js have their own scope, which can make it tricky to manage a truly global singleton.
So it's like trying to share a secret with everyone in a crowded room, but everyone is wearing noise-canceling headphones?
Exactly. The book dives into these challenges and offers alternative approaches that are more aligned with Node.js's modular nature.
All right, so singletons in Node.js require a bit more finesse. What about structural patterns? Can you give us a taste of those?
Structural patterns are all about how objects are composed and relate to each other,
Okay.
like building a house. Think about the relationships between walls, doors, windows, and the roof. They all work together to create a cohesive structure.
I like that analogy. So structural patterns are about building relationships between objects.
Exactly. One example is the proxy pattern,
Uh-huh.
which acts like a gatekeeper for an object, controlling access to it. It's like having a security guard at the entrance, checking credentials before allowing entry.
So the proxy pattern is all about adding a layer of security or control.
Exactly. You can use it to log access attempts, restrict certain operations, or even lazy load resources, ensuring that they're only loaded when needed.
It sounds like a powerful pattern for managing complex interactions between objects. What about the decorator pattern? How does that one work?
The decorator pattern is all about dynamically adding new behavior to an object without modifying its structure. Think of it like decorating a cake. You can add frosting, sprinkles, and other embellishments without changing the cake itself.
So it's about adding functionality without altering the core object. That's
Yeah.
a clever way to extend an object's behavior.
Exactly. Imagine you have a logging system,
Okay.
and you want to add the ability to write logs to different destinations, like a file, a database, or a remote server. You can use the decorator pattern to dynamically add these logging capabilities without modifying the core logging class.
That's a great example. It's like having a toolbox of different logging options that you can plug and play as needed. What about the last structural pattern, the adapter pattern?
The adapter pattern is like a universal translator for objects. It allows objects with different interfaces to communicate with each other. Think of it like an electrical adapter that allows you to plug a device from one country into an outlet in another country.
So it's about bridging the gap between incompatible interfaces. Can you give me a concrete example of how this pattern might be used?
Absolutely. Imagine you have a legacy system that uses an older API, and you need to integrate it with a newer system that uses a different API. The adapter pattern allows you to create a bridge between these two systems, enabling them to exchange data seamlessly.
That's a great example. It's like having a diplomat who can speak both languages, facilitating communication between two different worlds.
Exactly. The adapter pattern is a valuable tool for integrating different systems and components, ensuring smooth communication and data flow.
Okay, we've covered creational and structural patterns. What about behavioral patterns? They sound like they deal with the actions and interactions of objects.
You're exactly right. Behavioral patterns are all about how objects communicate and collaborate with each other to achieve a common goal. They're like a set of rules or protocols that govern the interactions between objects.
So it's like a social etiquette guide for objects, teaching them how to behave properly in different situations.
That's a great way to put it. And just like in human society, having clear rules and protocols can make interactions smoother and more efficient.
All right, I'm ready to learn about these object etiquette rules. What's the first behavioral pattern on our list?
Let's start with a strategy pattern. This pattern is all about defining a family of algorithms, encapsulating each one, and making them interchangeable. It's like having a toolbox full of different tools, and you can choose the right one for the job at hand.
So it's about flexibility and choosing the right approach for a given task. Can you give me a concrete example of how the strategy pattern might be used in Node.js?
Absolutely. Imagine you're building a payment processing system. You might need to support different payment methods, such as credit cards, PayPal, or Bitcoin. The strategy pattern allows you to define separate algorithms for each payment method and then dynamically choose the appropriate algorithm at runtime based on the user's selection.
That's a great example. So instead of having a monolithic payment processing function, you have a set of specialized strategies that can be swapped in and out as needed. What about the state pattern? How does that one work?
The state pattern allows an object to alter its behavior when its internal state changes. It's like a vending machine that behaves differently depending on whether it's in the ready-to-dispense state or the out-of-stock state.
So it's about objects that can adapt their behavior based on their current conditions.
Precisely. Imagine you're building a traffic light system. You could use the state pattern to model the different states of the traffic light: red, yellow, and green. Each state would have its own logic for determining when to transition to the next state.
That's a clear example. So instead of having a bunch of conditional statements to manage the traffic light's behavior, you have a set of well-defined states, each responsible for its own logic.
Exactly. And this makes the code more readable, maintainable, and extensible. It's much easier to add new states or modify existing ones without having to wade through a tangled mess of conditional logic.
This is fascinating. I'm starting to see how these behavioral patterns can bring order and elegance to complex systems. What about the template method pattern? That one sounds a bit more abstract.
The template method pattern defines the skeleton of an algorithm in a method, deferring some steps to subclasses. It's like having a recipe where you have a basic set of steps, but you can customize certain ingredients or cooking times to create different variations of a dish.
So it's about providing a blueprint for an algorithm, allowing for customization in specific steps.
Exactly. Imagine you're building a report generator. You could have a report generator class that defines the basic steps of generating a report: fetching data, processing data, and formatting the output. But you might want to create different types of reports, like a sales report, an inventory report, or a customer report.
So you could create subclasses for each report type, overriding the specific steps that need to be customized.
That's right. And the report generator class would act as the template, providing the overall structure of the algorithm while allowing for flexibility in the implementation.
This is a great way to promote code reuse and avoid duplication. Okay, what about the middleware pattern? What's its role in Node.js?
Middleware is a fundamental concept in Node.js, especially in web frameworks like Express.js. It's all about creating a pipeline of functions that can process incoming requests and outgoing responses. Think of it like an assembly line, where each station performs a specific task on the product as it moves down the line.
So it's a way to break down request handling into smaller, more manageable units.
Exactly. And each middleware function can perform a specific task, such as logging the request, authenticating the user, or parsing the request body.
It sounds like a powerful way to modularize request handling and add functionality without cluttering the core application logic.
Precisely. And the book showcases how middleware is used in real-world Node.js applications, highlighting its flexibility and versatility.
Okay, I'm starting to see how middleware can be a game changer for building robust and maintainable web applications. What about the command pattern? How does that one fit into the Node.js landscape?
The command pattern is all about encapsulating a request as an object,
Okay.
thereby letting you parameterize clients with different requests, queue or log requests, and support undoable operations. It's like having a remote control that can send different commands to a device, such as turning it on or off, changing the volume, or switching channels.
So it's about treating requests as first-class citizens, making them more manageable and flexible.
Exactly. Imagine you're building a text editor. You could use the command pattern to represent actions like typing, deleting, copying, and pasting. Each command would be an object that encapsulates the logic for performing the action.
That's a great example. So instead of having a bunch of functions scattered throughout your code, you have a set of well-defined command objects that can be invoked, queued, or even undone.
Precisely. And the book highlights how the command pattern can be applied in Node.js applications,
Right.
bringing structure and elegance to complex operations.
Okay, I'm starting to see how these behavioral patterns can transform the way we think about and design software. What about the last pattern on our list, the iterator pattern?
The iterator pattern provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. It's like having a universal remote control that can work with any TV, regardless of its brand or model.
So it's about providing a standardized way to traverse different types of collections without needing to know the details of how they're implemented.
Exactly. Imagine you have a collection of books. You could use an iterator to loop through the books one by one without needing to know whether the books are stored in an array, a linked list, or some other data structure.
That's a great example. It's like having a tour guide who can show you around a city, regardless of the specific streets and landmarks. So the iterator pattern is all about abstraction and simplifying data access.
Precisely. And the book shows how this pattern is used in Node.js to work with various data structures,
Okay.
making your code more readable and maintainable.
Wow, we've covered a lot of ground with design patterns. It's amazing how these patterns can bring order, structure, and elegance to our code. But the book doesn't stop there. It takes us on a journey to the world of universal JavaScript. What's in store for us there?
Universal JavaScript is all about breaking down the barriers between the server and the browser.
Okay.
It's about writing JavaScript code that can run in both environments, blurring the lines between front-end and back-end development. It's a paradigm shift that opens up a whole new world of possibilities.
This sounds exciting, but I can't help but wonder, are there challenges in trying to make Node.js code work seamlessly in a browser environment?
You're absolutely right. Node.js and the browser are like two different planets with their own sets of rules and APIs. But fear not.
Uh-huh.
The book has got us covered. It guides us through the challenges and introduces solutions like module bundlers and build-time code branching.
Module bundlers, are those like spaceships that transport our Node.js code to the browser planet?
That's a fantastic analogy.
Right.
Module bundlers, like Webpack, are essential tools for universal JavaScript development. They analyze your code, figure out the dependencies, and package everything into a neat little bundle that the browser can understand.
So it's like packing a suitcase for an interplanetary trip,
Yeah,
making sure you have everything you need to survive on the other side.
exactly. And the book dives into the intricacies of Webpack, showing how it can handle everything from code splitting to tree shaking, ensuring that you end up with an optimized bundle that's ready for the browser.
That's impressive. But what about those build time code branches you mentioned? What are those all about?
Build-time code branching allows you to create different versions of your code depending on the environment it's running in. Think about it like a choose-your-own-adventure book, where the story unfolds differently based on the choices you make.
So you're saying we can write code that adapts to either the Node.js environment or the browser environment,
Yes,
depending on where it's running.
that's right. This is crucial for handling things like environment-specific APIs, sensitive information, and other factors that might differ between the server and the client.
This is starting to sound like magic. So we can write code that magically transforms itself to fit the environment it's in. But what about the actual code itself? How do we write code that can run happily in both worlds?
That's where understanding the differences and commonalities between Node.js and the browser becomes crucial. The book introduces React, a popular JavaScript library for building user interfaces.
React. I've heard great things about it. It's known for its component-based approach to UI development. But how does React help us with universal JavaScript?
React components are like versatile building blocks that can be rendered on both the server and the client. They're like chameleons that can adapt to their surroundings.
So we can write React components once and use them in both Node.js and the browser? That's awesome. But the book goes beyond just rendering React components. It talks about universal rendering, routing, and data retrieval. What are those all about?
Universal rendering is like sending a pre-rendered snapshot of your application to the browser.
Okay.
It gives the user something to look at while the JavaScript is downloading and executing in the background.
So it's about providing a faster initial experience for the user.
Exactly. It also has SEO benefits
Okay.
because search engines can easily index the pre-rendered content.
That makes sense. So universal rendering is about speed and SEO. What about universal routing?
Universal routing means using the same routing logic on both the server and the client. It's like having a GPS system that works flawlessly whether you're driving or walking.
So it's about ensuring a seamless navigation experience regardless of where the rendering takes place. What about universal data retrieval?
Universal data retrieval is about fetching data in a way that works on both the server and the client.
Okay.
This might involve prefetching data on the server for the initial render,
Right.
and then fetching additional data on demand as the user interacts with the application.
So it's about creating a unified data layer that can serve both sides of the application.
Exactly. And the book dives into the details of how to implement these universal concepts, showing how they work together to create a truly seamless and engaging user experience.
This is all so impressive. It's incredible how much thought and innovation goes into building modern web applications. But there's one more thing that caught my eye. The book mentions a section called Advanced Recipes. What's cooking in that section?
The Advanced Recipes section is like a treasure trove of practical solutions for specific challenges you might encounter when building real-world Node.js applications.
Okay, I'm intrigued. What kind of challenges do these recipes address?
One of the recipes tackles the problem of handling asynchronously initialized components. Remember how require is synchronous. Well, that can cause issues when you have components that need to do some asynchronous setup before they're ready to be used.
That sounds like a recipe for trouble. How do we handle that?
Yeah. The book offers a clever solution using the state pattern. It involves creating an initial queuing state that intercepts calls and queues them until the asynchronous setup is complete.
Okay.
Once initialized, the component transitions to an initialized state and processes those queued calls.
So it's like having a waiting room for requests until the component is ready to receive visitors.
Exactly.
Uh-huh.
And this pattern can be applied to a wide range of scenarios where you need to gracefully handle asynchronous initialization.
This is incredible. It's amazing how we can leverage design patterns to solve these complex challenges and build robust and reliable applications. But I have a feeling we've only just scratched the surface of what Node.js design patterns has to offer.
You're absolutely right. There's a whole universe of patterns and techniques waiting to be explored. It's like we've been given a map to this vast, uncharted territory.
And we've got the perfect guide to lead us through it. This book really is a treasure trove of knowledge. It's not just about learning individual patterns. It's about developing a deep understanding of how to build robust, scalable, and efficient Node.js applications.
Speaking of scalability, the next section of the book tackles this head-on. It's time to explore how we can take our Node.js applications to the next level, handling increased traffic, managing complexity, and ensuring high availability.
This is where things get really interesting, for real-world applications. So how do we go from a single-threaded Node.js process to a system that can handle the demands of, like, a global user base?
Well, the book covers a range of architectural patterns, from the simple and straightforward to the complex and sophisticated.
Okay, let's start with the basics. What's the simplest way to scale a Node.js application?
The most straightforward approach is cloning. Imagine you have a single server running your application. Cloning involves creating multiple copies of that server, each running an identical instance of your application.
So it's like having an army of clones, each handling a portion of the incoming traffic.
Exactly. And by distributing the workload across multiple servers, you can significantly increase your application's capacity and resilience.
That makes sense. But managing multiple clones manually sounds like a logistical nightmare. How do we ensure that traffic is distributed evenly across the clones and that failed clones are handled gracefully?
That's where load balancers come in. A load balancer acts as a traffic cop, directing incoming requests to different servers based on factors like server load, availability, and geographic location.
So it's like having an intelligent traffic management system that ensures smooth and efficient flow of traffic across multiple lanes.
Precisely. Load balancers are essential for building scalable and reliable systems. And the book dives into different types of load balancers. Their advantages and disadvantages, and how to choose the right one for your needs.
Okay, load balancing sounds like a crucial piece of the scalability puzzle, but cloning still involves running multiple instances of the same application. What if our application becomes so complex that it's difficult to manage as a single unit?
That's where microservices come in. Instead of building a monolithic application, the microservices approach involves breaking down your application into smaller, independent services that communicate with each other.
So it's like dividing a large empire into smaller, self-governing city-states, each with its own specialized function.
That's a great analogy. Each microservice can be developed, deployed, and scaled independently, making it easier to manage complex applications and adapt to changing requirements.
This sounds like a powerful approach to managing complexity, but it also introduces new challenges. How do these independent services communicate with each other? How do we ensure data consistency across different services? And what happens if one service fails?
You've hit on some of the key considerations when adopting a microservices architecture. The book explores these challenges in depth and offers solutions like API gateways, message queues, and service discovery mechanisms.
API gateways, message queues, service discovery, these sound like advanced concepts.
They are, but they're essential for building robust and resilient microservices-based systems. An API gateway acts as a single entry point for all your microservices, simplifying client access and providing features like security, rate limiting, and caching.
So it's like having a central reception area that directs visitors to the appropriate department.
Exactly. And message queues provide a way for microservices to communicate asynchronously, improving scalability and reliability. Think of it like a postal service that delivers messages between different departments, ensuring that messages are delivered even if the recipient is unavailable.
That's a clever way to decouple services and ensure reliable communication. What about service discovery?
Service discovery allows microservices to find and communicate with each other dynamically, even as the system scales and evolves. It's like having a phone book that automatically updates itself as new services are added or removed.
This is all starting to sound very complex. Is there a way to manage the deployment and orchestration of these microservices, especially when dealing with a large number of services?
That's where containerization and orchestration technologies like Docker and Kubernetes come in. Docker allows you to package your microservices and their dependencies into portable containers, making them easy to deploy and run consistently across different environments.
So it's like shipping your microservices in standardized containers that can be easily transported and deployed anywhere in the world.
Exactly. And Kubernetes provides a powerful platform for orchestrating these containers, automating tasks like deployment, scaling, networking, and health monitoring.
It sounds like Kubernetes acts as the conductor,
Yeah.
orchestrating this symphony of microservices. This is all incredibly fascinating. But before we get lost in the complexities of container orchestration, the book shifts gears and dives into a chapter on messaging and integration patterns.
Right. This chapter explores how to build applications that can communicate and share data effectively, especially in distributed environments like microservices architectures.
So it's all about connecting those independent services and enabling them to work together harmoniously.
Exactly. And the book covers a range of patterns, from the fundamental request-reply pattern to more sophisticated patterns like publish-subscribe, message queues, and event-driven architectures.
Okay, let's start with the basics. What's the request-reply pattern all about?
The request-reply pattern is the most basic form of communication between two services. It's like a conversation where one service asks a question, the request.
Right. And the other service provides an answer, the reply.
Okay, so it's a simple two-way communication, but wouldn't that create a bottleneck if the requesting service has to wait for the reply before it can continue?
That's a valid concern. The request-reply pattern can be implemented synchronously or asynchronously. Synchronous implementations can indeed lock the requesting service,
Right.
but asynchronous implementations allow the requesting service to continue processing other tasks while waiting for the reply.
So it's like sending an email and continuing with your day while waiting for a response, rather than sitting by the mailbox and constantly checking for mail.
Exactly. And the book explores different techniques for implementing asynchronous request-reply,
Okay.
like callbacks, promises, and message queues.
Okay, so we have options for handling request-reply scenarios. What about the publish-subscribe pattern? How does that one work? The publish-subscribe pattern is a more loosely coupled approach to communication. It involves publishers sending messages to topics and subscribers listening to those topics. The beauty of this pattern is that publishers don't need to know who the subscribers are, and subscribers don't need to know who the publishers are.
So it's like a radio station broadcasting a program.
Yes.
The radio station doesn't know who's listening,
Right.
and the listeners don't need to know who's broadcasting. They just tune in to the frequency they're interested in.
That's a great analogy. And the book explores different implementations of publish-subscribe, like message brokers and peer-to-peer networks.
Message brokers and peer-to-peer networks. Can you explain the difference?
Message brokers, like RabbitMQ or Kafka, act as intermediaries between publishers and subscribers. They provide features like message routing, persistence, and guaranteed delivery, ensuring that messages are reliably delivered even if the subscribers are unavailable.
So the message broker is like a central post office that handles the delivery of mail, ensuring that it reaches the intended recipient.
Exactly. And peer-to-peer networks allow publishers and subscribers to communicate directly with each other without a central broker. It's like sending messages directly to your friends without going through a postal service.
Okay, I see the difference. So far, we've discussed patterns for direct communication between services, either through request-reply or publish-subscribe. But what about those message queues we mentioned earlier? How do they fit into this messaging landscape?
Message queues are a powerful mechanism for handling asynchronous communication, especially in distributed systems. They act as temporary storage for messages, ensuring that messages are delivered even if the recipient is unavailable.
So it's like having a voicemail box that stores messages until you're ready to listen to them.
That's a perfect analogy. And the book explores different types of message queues like FIFO, first in, first out queues, which process messages in the order they are received, and priority queues, which allow you to prioritize certain messages based on their importance.
FIFO is like a regular line at the bank, while priority queuing is like having a special line for VIP customers.
Exactly. And the book delves into advanced message queue patterns, like competing consumers, where multiple consumers can process messages from a queue concurrently, improving throughput and scalability, and work queues, where messages represent tasks that need to be processed by workers.
It sounds like message queues are a versatile tool for managing asynchronous communication in a variety of scenarios.
They certainly are. And the book provides concrete examples of how to use message queues effectively in Node.js applications.
This is all incredibly fascinating. We've explored a wide range of messaging and integration patterns from the basic to the advanced. But the book doesn't stop there. It takes us even further down the rabbit hole with a chapter on event-driven architectures.
Right. Event-driven architectures are a paradigm shift in the way we think about building systems. They're all about reacting to events, rather than explicitly invoking functions or methods.
Okay, this sounds intriguing. Can you elaborate on what you mean by events?
An event represents a significant occurrence or a state change within a system. It's like a news announcement that signals something important has happened.
So events are like notifications
Yeah,
that broadcast changes or occurrences within the system.
exactly. And in an event-driven architecture, different components of the system can listen for and react to these events. It's a more loosely coupled and flexible approach to building systems, where components don't need to know about each other directly, they just need to know about the events they're interested in.
It sounds like a very reactive and dynamic way to build systems. Can you give me a concrete example of how an event-driven architecture might be used?
Absolutely. Imagine you're building an e-commerce platform. When a user places an order, that's an event. Different components of the system can listen for this event and take appropriate actions. The inventory management system can update stock levels, the payment processing system can charge the user's credit card, and the shipping system can prepare the order for delivery.
So it's like a chain reaction?
Yeah.
Where one event triggers a cascade of actions across different parts of the system.
Exactly. And the book explores different event-driven patterns,
Okay.
like event sourcing, where you store all changes to an application's state as a sequence of events, and CQRS, Command Query Responsibility Segregation, which separates the responsibility of handling commands, actions that change the system's state, from queries, requests for information about the system's state.
Event sourcing sounds like a powerful way to track the history of changes and understand how the system reached its current state. And CQRS seems like a good way to decouple different parts of the system and improve performance.
They're both powerful patterns that can be used effectively in event-driven architectures.
Okay, so far we've journeyed through the land of scalability patterns, messaging patterns, and event-driven architectures. It's incredible how much depth there is to the world of Node.js. But the book keeps on giving. What's next on our agenda?
Now it's time to dive into the Advanced Recipes section. This is where the book shares practical solutions for specific challenges you might encounter when building real-world Node.js applications.
I'm always up for a good recipe. What kind of challenges are we talking about?
One of the recipes addresses the problem of handling asynchronously initialized components in a messaging context. Remember how we discussed the challenges of synchronously loading modules with require when dealing with asynchronous operations? Well, this recipe provides a clever solution using the state pattern.
So it's about gracefully handling those situations where a component needs to do some asynchronous setup, like connecting to a message broker
Yeah.
before it's ready to process messages.
Exactly. The pattern involves creating an initial queuing state that intercepts calls and queues them until the asynchronous setup is complete. Once a component is initialized, it transitions to an initialized state and processes the queued calls.
It's like having a waiting room for messages until the component is ready to receive them.
Precisely. And this pattern can be applied to a wide range of scenarios where you need to handle asynchronous initialization in a robust and reliable manner.
This is a great example of how design patterns can help us solve real-world problems in a clean and elegant way. What other recipes does the book have in store for us?
Another recipe focuses on asynchronous request batching and caching in a messaging context. This is all about optimizing performance when dealing with multiple requests that involve message queues or other asynchronous communication mechanisms.
Batching and caching. Those sound like familiar concepts from other domains. How do they apply to messaging?
Asynchronous request batching involves grouping multiple messages together and sending them as a single batch, reducing overhead and improving efficiency. It's like sending a package instead of multiple letters.
That makes sense. And caching involves storing the results of expensive operations,
Yes.
like message processing or database queries,
Right.
to avoid repeating them unnecessarily.
Exactly. It's like having a library of pre-processed messages that can be accessed quickly, saving time and resources.
These optimization techniques can be a game changer for high-performance messaging systems.
Absolutely. And the book provides practical guidance on how to implement batching and caching effectively in your Node.js applications.
This is all incredibly valuable information. What other gems are hidden in this recipe collection?
Well, there's a recipe for implementing cancelable asynchronous operations in a messaging context. Have you ever sent a message and wished you could recall it before it was processed?
Oh, absolutely. Like when you accidentally send an email to the wrong person and desperately try to retract it before they see it.
That's a perfect example. This recipe provides techniques for gracefully canceling asynchronous operations that involve messaging, ensuring that messages are properly handled and preventing potential issues.
So it's like having an undo button for those accidental messages. Very useful.
Indeed. And there's a recipe for handling back pressure in a messaging context. Imagine a message queue that's receiving messages faster than they can be processed. This can overwhelm the system and lead to failures.
So it's like a traffic jam in a message queue where messages are piling up and blocking the flow.
Exactly. Back pressure is a mechanism for regulating the flow of messages, ensuring that the system doesn't get overloaded. It's like having a pressure valve that releases excess pressure and prevents the system from bursting.
That's a crucial mechanism for maintaining the stability and reliability of a messaging system.
Absolutely. And the book explores different techniques for implementing back pressure,
Okay.
like flow control mechanisms and rate limiting.
Okay, back pressure sounds like a must-have for any serious messaging system. What about the last recipe in this chapter?
The final recipe focuses on implementing the request-reply pattern using AMQP, a popular messaging protocol. It provides a step-by-step guide to using AMQP features like message queues, routing keys, and correlation IDs to build robust and reliable request-reply communication.
So it's a practical guide to using AMQP
Yeah.
for those scenarios where you need a guaranteed response to your request.
Exactly, and it highlights the power and flexibility of AMQP as a messaging protocol.
Wow, this advanced recipe section is truly a goldmine of practical knowledge. It's like having a secret cookbook filled with expert tips and tricks for mastering Node.js development.
It's a testament to the maturity and versatility of Node.js that it can handle such a wide range of scenarios and challenges.
Okay, we've covered a vast landscape of patterns and techniques, from the fundamental building blocks of Node.js to the intricate details of scalability, messaging, and event-driven architectures. It's been an incredible journey. But I feel like we're just getting started. There's still so much to explore and discover in the world of Node.js.
You're absolutely right. This book is just the beginning. It's like we've been given a glimpse into this vast and ever-expanding universe of possibilities.
And we have the tools and knowledge to navigate this universe with confidence.
Speaking of tools and knowledge, the book wraps up with a section called Other Books You May Enjoy. It's a curated list of books that can further enrich your understanding of web development concepts, from the foundations of HTML, CSS, and JavaScript to specific frameworks and libraries.
It's like the book is handing us a treasure map, guiding us towards new and exciting adventures in the world of web development. I love how this deep dive has not only illuminated the world of Node.js design patterns, but has also opened doors to further exploration.
Learning is a continuous journey, and this book encourages us to keep exploring, keep experimenting, and keep pushing the boundaries of what's possible with Node.js.
Absolutely. But before we embark on our next adventure, let's take a moment to recap what we've learned on this incredible deep dive.
We started with the Node way, the philosophy that permeates the entire Node.js ecosystem. It's all about embracing the unique characteristics of Node.js, its single-threaded nature, its asynchronous programming model, and its modular design. It encourages us to write small, focused modules, expose only essential functionality, and leverage asynchronous patterns to maximize efficiency and concurrency.
It's about working with the grain of Node.js rather than against it.
Precisely. And we saw how these principles are embodied in the various design patterns we explored, from callbacks and promises to streams and event-driven architectures.
Let's talk about callbacks for a moment. They're the workhorses of asynchronous programming in Node.js,
Yeah.
but they can also lead to the dreaded callback hell. What are some strategies for taming those callback beasts and keeping our code clean and maintainable?
Well, the book offered some practical advice. We can use early return to exit functions as soon as possible, preventing unnecessary nesting. Modularization is another key technique. breaking down complex logic into smaller, reusable functions. And for those scenarios where we need things to happen in a specific order, we can employ techniques like nested callbacks or leverage libraries like async to manage the flow of execution.
Those are great tips. It's all about writing code that's not only functional, but also readable and maintainable.
Absolutely. And that's where promises come in. They offer a more elegant and structured way to handle asynchronous operations with built-in mechanisms for handling success and failure paths.
Promises are like a breath of fresh air compared to those nested callback pyramids. They make our code cleaner, easier to understand, and less prone to errors.
And with Async Await, we can even write asynchronous code that looks and feels almost synchronous, making it even more readable and enjoyable to work with.
It's like magic. But it's important to remember that even with Async Await, Node.js is still single-threaded at its core. The magic lies in how it manages those asynchronous operations behind the scenes, using mechanisms like the task queue to ensure that everything runs smoothly and efficiently.
That's right. Node.js is a master of illusion, making complex asynchronous operations appear effortless. But let's not forget about streams. They're essential for handling large amounts of data or performing I/O-heavy operations.
Streams are like powerful pipelines
Yeah.
that allow us to process data in chunks rather than waiting for the entire data set to be loaded into memory. They're incredibly efficient, especially when dealing with huge files or real-time data.
Exactly. And we have a variety of stream types at our disposal. Readable streams for reading data, writable streams for writing data, duplex streams for two-way communication, and transform streams for modifying data as it passes through the pipeline.
It's like having a plumbing system for data, with different types of pipes and connectors to manage the flow. And we can even combine and manipulate streams in sophisticated ways, using advanced stream patterns like merging, combining, multiplexing, and demultiplexing.
Streams are truly a versatile tool for managing complex data flows. But let's shift our focus back to traditional design patterns. We explored a wide range of them, from creational patterns, which control how objects are created, to structural patterns, which define how objects are composed and relate to each other, to behavioral patterns, which govern how objects communicate and collaborate.
These patterns are like time-tested recipes for building well-structured, maintainable, and extensible code.
And even though Node.js has its own unique characteristics, the underlying principles of good software design remain timeless. We saw how patterns like the factory, builder, revealing constructor, and singleton can be applied effectively in the Node.js context, bringing order and clarity to object creation.
And we explored structural patterns like the proxy, decorator, and adapter, which provide powerful mechanisms for controlling access, adding functionality, and bridging incompatible interfaces.
And we delved into the world of behavioral patterns, learning about the strategy, state, template method, middleware, command, and iterator patterns. These patterns provide elegant solutions for managing algorithms, states, communication, and data access.
It's incredible how these patterns, which have been around for decades, are still so relevant in the modern world of Node.js development.
They represent a wealth of knowledge and experience. Distilled from countless hours of software development, they provide us with a common language for communicating about software design and a toolbox filled with proven solutions to common problems.
But the book doesn't stop there. It takes us on an exciting journey into the world of universal JavaScript, where we break down the barriers between the server and the browser, writing code that can run in both environments.
Universal JavaScript is a paradigm shift that empowers developers to create more efficient, performant, and maintainable web applications. And the book guides us through the challenges and solutions, introducing tools like module bundlers, build-time code branching, and frameworks like React, which are essential for building truly universal experiences.
Universal rendering, routing, and data retrieval are just a few examples of how we can blur the lines between front-end and back-end development, creating a more unified and seamless web experience.
It's an exciting time to be a web developer, and this book equips us with the knowledge and skills to embrace the power and possibilities of universal JavaScript.
This deep dive has been an incredible journey, filled with insightful discoveries and practical takeaways. But before we conclude our exploration, let's step back and consider the bigger picture. What are some key takeaways from this journey through the world of Node.js design patterns?
Well, I think there are three main takeaways. One, understanding the Node way. The book emphasizes the importance of understanding the core principles of Node.js and how they influence design decisions. It's not just about learning patterns. It's about understanding why those patterns work so well in this environment. Two, embrace asynchronicity.
Right.
Node.js is inherently asynchronous, And the book provides a comprehensive toolkit for mastering asynchronous programming, from callbacks and promises to streams and event-driven architectures. 3. Design for scalability and maintainability.
Okay.
The book goes beyond single-threaded Node.js and explores patterns for building applications that can handle increased traffic, manage complexity, and ensure high availability.
Those are fantastic takeaways. It's not just about learning specific patterns, it's about developing a mindset for building robust, scalable, and efficient Node.js applications.
Precisely. And the book empowers developers to do just that.
Okay, it seems like we've reached the end of our journey through the world of Node.js design patterns. But before we say goodbye, let's leave our listener with a final thought, something to ponder as they continue their own explorations.
As you delve deeper into Node.js and its ecosystem, remember that patterns are not rigid blueprints, but rather guidelines and inspiration for solving problems effectively. Don't be afraid to experiment, adapt, and even create your own patterns as you gain experience. The possibilities are endless.
That's a great reminder. This deep dive has definitely sparked my curiosity and given me a solid foundation to explore further.
Yeah, and speaking of exploration, you mentioned earlier that you were particularly intrigued by universal rendering. It's a fascinating concept that can really boost the performance and SEO of your Node.js web applications.
It is. The idea of sending a pre-rendered snapshot of the application to the browser just seems so smart. It's like giving the user a sneak peek while the full experience loads in the background.
Exactly. It's all about providing a smoother and faster user experience. Instead of staring at a blank screen while the JavaScript bundles download and execute, the user sees a fully rendered page almost instantly. This could significantly improve perceived performance, especially on slower connections or mobile devices.
And it's not just about perceived performance. The book mentioned SEO benefits as well. Can you elaborate on that?
Absolutely. Search engines love content that is readily available. With universal rendering, search engine crawlers can easily index that pre-rendered HTML, even if they don't execute the JavaScript. This can give your application a significant SEO boost, making it more discoverable and improving its search ranking.
So universal rendering is a win-win for both users and search engines. I'm starting to see why it's becoming such a popular technique for modern web applications. But the book also mentioned universal routing and data retrieval. How do those fit into the picture?
Universal routing ensures that the same routing logic is used on both the server and the client, providing a consistent navigation experience regardless of where the rendering takes place. It's like having a seamless GPS system that guides you smoothly whether you're driving or walking. No more jarring transitions or unexpected detours.
That's a great way to put it. Consistent navigation is crucial for a smooth user experience. And what about universal data retrieval?
Universal data retrieval is about fetching data in a way that works seamlessly on both the server and the client. For the initial render, you might prefetch data on the server to provide a fully populated page. But as the user interacts with the application, you might need to fetch additional data on demand from the client.
So it's about creating a smart data layer that knows how to fetch data from the right place at the right time.
Yeah.
Ensuring a fast and responsive user experience.
Exactly. And the book dives into the details of how to implement these universal concepts using React and other popular frameworks.
This is all incredibly exciting. Universal JavaScript really does blur the lines between front-end and back-end development, opening up a whole new world of possibilities for building web applications. It's like we've entered a new era of web development.
I couldn't agree more. And this book provides the roadmap for navigating this new era. It's packed with practical guidance, insightful explanations, and real-world examples that can help you build robust, scalable, and efficient Node.js applications.
Well, it seems like we've reached the end of our deep dive into the world of Node.js design patterns. It's been an incredible journey.
It has. We've explored the depths of Node.js, from its core principles to its advanced capabilities. We've learned about a wide range of patterns and techniques can help us build better software, from small modular components to large distributed systems.
But the journey doesn't end here, right?
Right.
This deep dive has sparked our curiosity and inspired us to continue exploring, learning, and experimenting.
As you continue your Node.js journey, remember the patterns are not rigid rules, but rather guidelines and inspiration for solving problems effectively. Don't be afraid to adapt, experiment, and even create your own patterns as you gain experience and encounter new challenges.
That's a great point. The world of software development is constantly evolving, and Node.js is no exception. New libraries, frameworks, and patterns emerge all the time. It's up to us to stay curious, keep learning, and keep pushing the boundaries of what's possible.
And as you delve deeper into the Node.js ecosystem, remember the Node way. Embrace asynchronicity, modularity, and simplicity. These principles will guide you towards building elegant, efficient, and maintainable applications.
Well said. Thanks for joining me on this deep dive into the world of Node.js design patterns. It's been an enlightening and inspiring journey.
The pleasure was all mine. Until next time, happy coding.